Hi guys, this is Mrs. Millis, and Mr. Millis is here too. With the next video for Power Standard 2, you just talked about the three states of matter, also known as the phases of matter. You got gas, liquid, and solid. Now we're going to talk about actually them changing from one into the other. So keep in mind that within matter, atoms are constantly in motion. So everything is continually moving. I know we talked about in my class how even in a solid, the atoms are vibrating in place. There is that constant movement. And then we can kind of see more movement in liquids and gases. It's kind of easier to visualize that. So the movement of the atoms depends on the substance in its current state, solid, liquid, or gas. So we're going to start at the gaseous state because that's what's on top actually, obviously. And considering the gas, a substance is a gas when it is at a higher amount of, it has a higher amount of energy. So these molecules, these particles here, have more energy than their counterparts at the liquid or solid phases. So I like to use water as an example because I'm pretty sure that's something we've all experienced, assuming that you are the common earthling. And then when water is at a gaseous state, it does move at a quicker rate. The water molecules are spreading out, and they kind of act random. They have random motion. So the particle motion I would describe is that the molecule, you probably won't be able to see that. Where's my pen? I'm prepared. Don't worry. The molecules are in constant motion. So that means there is a lot of what we're going to call kinetic energy. Kinetic energy is the energy of movement. In the molecules, we're going to add a little sidebar here. They're farther apart. And I'm going to get my yellow and I'm going to kind of highlight that. So notice they're not next door neighbors. They're further apart and they expand more. So I'm also going to highlight they're in constant motion. I feel like some of you guys are in constant motion. And some of you have a lot of kinetic energy. A lot. You're always in motion. So if I look at the thermal energy, thermal means it's related and correlated to the temperature in an object, how much heat it has. Thermal is another word for heat. If you've ever heard it in the context of thermal underwear, that is something that you wear in the wintertime to keep yourself nice and cozy and warm. Well, only the bottom half, I guess. So thermal energy is the measure of how much heat is in that system. So if I was to color this thermometer, I'm going to color it all the way up with my traditional red for the thermometer. And then that is indicating that there's rapid movement of particles. I want you to consider a thermometer itself for a minute here with me. The thermometer actually expands. If you think about a thermometer that's hot versus a colder thermometer, the hotter thermometer rises all the way up to the top of the colder thermometers down here at the bottom. But no one added liquid inside the thermometer. The only thing that changed is the distance between the red particles. In a traditional thermometer, it's alcohol inside of it. We don't go to the old time where they have mercury. But the alcohol atoms get further apart, which causes it to rise. Think about that. So we're going to do a couple examples of a phase change. So we're going to go from gas down to our friend liquid. Okay, so we're taking the water vapor, for instance, and we're going to do what's called condensing into a liquid. So that water vapor becomes a liquid. So I see this. I'm actually going to do the examples last. I'm going to do the examples first. So with condensation, kind of have a pet peeve here. In a hot summer day, you have a nice drink. Maybe you're drinking some lemonade while you're sitting there by the pool, just chilling, being kind of savage. Sometimes when you drink your lemonades, you'll notice on the outside of your glass there's some like sweat. I've had some of my family members call it sweat. There's like water droplets. on the outside of the glass. And I've had family members that think that the liquid from inside the glass somehow magically seeped through the glass to the outside, and they're just kind of wrong. That doesn't happen. It doesn't make sense, especially if it's lemonade. It would be yellow on the outside and sticky and sweet. But instead, this is water that's in the air as a gas already, but when it touches the cool cup, and the glass got colder because there's ice in there, and then the water droplets from the air that's all around us naturally turn to gas or turn to liquid when it contacts the glass. So condensation that you see, and it's most common with I'm thinking like beverages. I also get it with my glasses when I go for them out or inside, and then I go outside immediately in a winter day. It gets all condensated in there, kind of annoys me. So that's what condensation is. It's going from a gas to a liquid. Let's remind ourselves what a liquid is. So liquid has all these molecules, and liquid water is kind of fun, right? We kind of need it to live. 3 days without it, and adios. Liquid particles, they have movement. The oh my goodness, I can't spell. Molecules flow or slide over one another. And they have more kinetic energy than solid, less than gas. That's why they're in the middle. So I'm going to highlight the word slide here and flow. And then I want to show you, I'm going to get my dark marker color and show you how they kind of slide and flow. Notice that these lines are a little bit more curvy. As liquids don't have a direct path, the gases were more straight lines because that's how they tend to travel, but the liquids will have a little bit more random motion. In the thermal energy, there's just some movement. So that means the red liquid in our thermometer is not going to be quite as high. It's going to be higher, but not quite as high. Now, let's think of a time where we've had a liquid water and it turns into a gas. So we're going to go reverse. And I am thinking of times where I cook the macaronis and cheese. Or you can do your ramen, if that's the type of person you are, and you do it old school on a stove. You got your nice little pot. You got your fire underneath, right? Ooh, that's hot. And then inside it, you have your water. And it starts to boil over, and then you got the stuff coming up. That still, my friends, is water. You did not separate water molecules, so these are still little H2Os that are now in a gaseous form. They're still connected, two hydrogens connected to an oxygen, but it's in a gaseous form. So that steam that you're seeing bubbling up, that is water vapor. So let's say the word vapor here. And that's called evaporation. So you can do that through boiling water, or you just leave stuff out over time. Sometimes water just evaporates over time. If you leave this macaroni and cheese unattended, then you sometimes boil the whole water pot out. That's frustrating. Okay, let's go to my favorite state of matter, solid. Don't you have a favorite state of matter? I am a solid. That's why it's my favorite. So notice these molecules, and it's not by design or accident. These molecules are super close together. However, there is some movement. So let's take our pen, and it's really important when I see this in assessment that you show me, well, you really can't see that, but that's okay. Oh, I used my dark color. You show me the movement of these, and we're going to see it through just these little lines that they use in like cartoons to show movement. And we're going to say that the particle motion is that the molecules are held close together and vibrate. I know in my classes we talked about how everything is vibrating, and then that, molecules in glass vibrate, and if you hit the right frequency, if you're singing, you can, and you match that frequency of the vibration of the glass, they actually going to cause the glass to like bust. And it's like a goal of some singers is to like have glass break when they sing. The only thing that happens when I sing is children cry, usually. If you ask for it in class, ask me to sing, I will give you 5 extra credit points. I like to sing the Havana song. It's fun. Okay, so the molecules in a solid do vibrate in place, even though we can't feel it. So on my kitchen table, they're vibrating in place. I can't feel it. The molecules in my bones are vibrating in place, and my crayons are vibrating, but we don't know because atoms are pretty darn small. Okay, let's look at our thermometer. It's a solid, so this tends to be a lower temperature. So there is slower movement of particles. Okay, now let's go ahead and switch from a solid. Let's go up to a liquid. If I have an ice cube and it's turning into water, we call that melting. It also happens when witches get wet. They tend to melt. So I'm going to draw an example of melting right here. And I don't think I'll draw the Wicked Witch of the West. I think I'll draw instead our classic ice cubes. Butter melts. Gold melts. Have you ever seen like a woodsmith? Not a woodsmith. Why would a woodsmith use gold? What's it called?
Blacksmith.
A blacksmith. Sorry, I knew it was some sort of smith. And he can melt gold if he applies enough heat to the gold. So as you add heat, ice will melt. As you add heat, metals will melt. And someone in class the other day asked me, does everything melt? And the answer is no. I've never seen wood melt. Wood instead is something that's more combustible. It's going to burn. So many things do melt, but not everything does. Okay, so now let's go from a liquid and let's add some coldness, which really means taking away heat, because cold is just the absence of heat, just like dark is the absence of light. So let's go freezing. If we're going to freeze something, I'm thinking about like maybe in the wintertime, you're going to go down to that one place. I forget what it was called, that one rink, ice skating rink. Look at that. This is beautiful drawing here, but you can't do better. And we have a lake that's frozen, right? So there's my beautiful ice skates. And maybe it snowed. So that raindrop in the air has frozen on its way down. So freezing is when it goes from a liquid and it loses some of its kinetic energy and it gets turned into a solid. Okay, friends, you have 3 states of matter, and then you have 4 ways of which things are changing between them. There are examples of times where it goes straight to a solid to a gas and straight from a gas to a solid. However, in 7th grade, we're not going to cover that. So you're lucky ducks. You get a couple years off. If you have any questions, come see your science teacher. And after this, you only have 3 assignments left. Okay? So you're almost done with the standard. Good work.